Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 23, Episode 65, full broadcast on the 29th of June, 2020. Coming up on SpaceTime, the ancient eruption at the heart of the Milky Way galaxy that still shines bright millions of years later. OSIRIS-Rex asteroid sample collection set down for October 20, and an annular solar eclipse captivates the world as it sweeps across Africa, Asia, and the Pacific. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
About 3.5 million years ago, a supermassive black hole at the center of our Milky Way galaxy suddenly unleashed an enormous burst of energy. This blast was so powerful, the early hominids, ancestors of modern-day humans roaming across the savannas of Africa, would have noticed this gigantic flare as a ghostly glow high overhead in the constellation Sagittarius, lasting for maybe 1 million years. Now, eons later, astronomers using NASA's Hubble Space Telescope are uncovering more clues about this cataclysmic explosion. Looking to the far outskirts of the Milky Way galaxy, they found that the black hole's floodlight has now reached so far into space, it's illuminated a vast train of gas trailing the Milky Way's two prominent satellite galaxies, the Large and Small Magellanic Clouds. The outburst was probably caused by a massive cloud of hydrogen gas, maybe 100,000 times the mass of our Sun, collapsing down onto the accretion disk of material swirling around the black hole's event horizon. The resulting blast sent cones of blistering ultraviolet radiation high above and below the plane of the galaxy and deep into space. The radiation cone that blasted out of the Milky Way's south pole lit up a massive ribbon-like gas structure called the Magellanic Stream. This Magellanic Stream of gas and dust connects both the Large and Small Magellanic Clouds with the Milky Way itself, and is thought to be caused by gravitational tidal interactions as our galaxy slowly begins to cannibalize the Magellanic Clouds. Now, a report in the Astrophysical Journal claims the flash lit up a portion of the stream, ionizing its hydrogen, enough to make 100 million suns, by stripping electrons away from their protons. The study's lead author, Andrew Fox, from the Space Telescope Science Institute in Baltimore, Maryland, says the flash was so powerful it lit up the stream like a Christmas tree, a truly cataclysmic event. In fact, this shows astronomers how supermassive black holes can impact not just their own galaxies, but also those around them. Fox says it also shows how different regions of the galaxy are linked. What happens in the galactic center really does make a difference to what happens out in the Magellanic Stream. The authors used Hubble's ultraviolet capabilities to probe the stream by using background quasars, the bright cores of distant active galaxies, as light sources. Hubble's cosmic origin spectrograph can see the fingerprints of ionized atoms in this ultraviolet light from the quasars. The authors studied sightlines to 21 quasars far behind the Magellanic Stream and 10 behind another feature called the leading arm, a tattered and shredded gaseous arm that precedes the Magellanic Clouds in their orbit around the Milky Way. When light from the quasars pass through the gas, some of it at specific wavelengths gets absorbed by atoms in the cloud. And when astronomers looked at the quasar light spectrum at specific wavelengths, they see evidence of light absorption that they wouldn't see if the light hadn't passed through the cloud. And that tells them something about the gas itself. The authors found evidence that the ions had been created in the Magellanic Stream by an energetic flash. This burst was so powerful it lit up the stream, even though it's an incredible 200,000 light-years away from the galactic center and the source of the explosion. Interestingly, unlike the Magellanic Stream, the leading arm didn't show any evidence of being lit up by the flare. And that makes sense because the leading arm isn't sitting right below the South Galactic Pole, so it wasn't showered with the burst's radiation. Another interesting point, this same event which caused this radiation flare we're talking about also generated those hot plasma Fermi bubbles we talked about last week those massive bubbles towering some 30,000 light-years above and below the plane of the Milky Way. Their energetic gamma-ray glow was discovered in 2010 by NASA's Fermi Gamma-Ray Space Telescope. And as we mentioned in last week's story, in 2015, Fox used Hubble's ultraviolet spectroscopy to measure the expansion, velocity and composition of the ballooning lobes. And now Fox and colleagues have managed to stretch Hubble beyond the Fermi bubbles. Fox says he always thought the Fermi bubbles and the Magellanic Stream were separate and unrelated to each other, each doing their own thing in different parts of the galaxy's halo. But he now sees that the same powerful flash from the Milky Way's 4.3 million solar mass black hole played a major role in both. This is SpaceTime. Still to come, OSIRIS-Rex's asteroid sample collection set down for October 20, and a spectacular annular solar eclipse sweeps across Africa, Asia and the Pacific. All that and more coming up on SpaceTime. NASA has set October 20 as the date when the OSIRIS-Rex spacecraft will maneuver down to the rugged, boulder-strewn surface of the asteroid Bennu and attempt to collect a sample of the ancient space rock for return to Earth. The Touch and Go, or TAG sample collection event, will be the culmination of more than a decade of planning and work. Mission managers carried out a successful first rehearsal back on April the 14th, and a second has been slated for August 11. The original target date for sample collection was planned for late August, but the new October 20 date will allow more time to prepare in the wake of the COVID-19 pandemic. 101955 Bennu is what's known as an Apollo Group asteroid. That means it's a near or near-Earth object on an orbit which intersects with and crosses Earth's orbit around the Sun. Bennu is classified as a Type B carbonaceous asteroid, generally similar to Type C carbon asteroids, but with surface spectra suggesting anhydrous silicates, hydrated clay minerals, organic polymers, magnetite and sulfides. The 492-metre-wide space rock has an intrinsically dynamically unstable orbit with a significant 1 in 2,700 chance of hitting the Earth between 2175 and 2199. That's one of the highest confirmed impact probabilities of any asteroid. Now, if it were to collide with the Earth, the resulting impact would be the equivalent of a 1,200 megaton thermonuclear device. Launched from the Cape Canaveral Air Force Station in Florida aboard an Atlas V rocket back on September the 8th, 2016, the 2,110-kilogram OSIRIS-Rex spacecraft arrived at Bennu in October 2018. The probe spending 3 years orbiting the asteroid at altitudes as low as 5 kilometers, mapping Bennu's surface and geology, studying its evolution, chemistry and mineralogy. One of its key mission objectives involves studying non-gravitational influences, such as the Joukowsky effect, in which sunlight heats up the surface of an asteroid and that heat is then radiated back into space as the asteroid rotates, providing a small amount of thrust. Knowing Bennu's physical properties will be critical for scientists trying to determine the likelihood of this mountain-sized asteroid slamming into the Earth. When OSIRIS-Rex undertakes its sample collection, it won't actually touch down on the surface, but will hover just above, extending a robotic arm down to collect about 2 kilograms of pristine asteroid regolith for sample return to Earth. The spacecraft is slated to leave Bennu orbit in March 2021, with a sample return capsule being jettisoned for a parachute landing in Utah in September 2023. This is SpaceTime. Still to come, an annular solar eclipse sweeps across Africa, Asia and the Pacific, providing a spectacular celestial display. And China launches more spy satellites, bringing its total Earth observation fleet to well over 90. All that and more still to come on SpaceTime. People across parts of Africa, Asia and the Pacific have been treated to a spectacular annular solar eclipse timed to coincide with the June solstice. Solar eclipses happen when the moon's orbit lines up in such a way that it passes directly between the Earth and the Sun. See, the moon's orbit around the Earth is actually inclined by about 5 degrees compared to Earth's orbit around the Sun. So normally, the moon's orbit appears to cross the sky either slightly above or slightly below the path of the Sun. But roughly every 18 months or so, the lunar orbit places the moon directly between the sun and the Earth, resulting in a solar eclipse. Eclipses happen because although the moon's some 400 times smaller than the sun, it's also some 400 times closer to the Earth, and so the two appear to be the same size in the sky as seen from Earth. When the sun, moon, and Earth line up exactly, the Earth experiences a total solar eclipse. As this occurs, the moon begins to slowly pass in front of the sun, and a partial lunar shadow or penumbra crosses the surface of the Earth. And this can last over an hour, as more and more of the sun is hidden by the face of the moon. Then, just before totality occurs, the crescent sun converges into a single brilliant white diamond of sunlight as the very last bits of the sun's bright disk shines along the edge of the moon, and the first glimpses of the faint corona create a ring around the moon, an effect known as the diamond ring. Then, in the last fleeting moments before totality, the diamond ring breaks up into a string of beads, created as the sun's rays shine through the low-lying valleys between the mountains along the limb or edge of the moon. Once this effect, known as Bailey's beads, ends, the moon has completely covered the entire disk of the sun, and you're in totality. During totality, the darkest part of the moon's shadow, known as the umbra, crosses the Earth's surface. During this time, the sky is dark, stars will appear, it'll suddenly get noticeably cooler, birds will start roosting, shadows will take on an unusual crescent shape, and you'll be able to see the sun's tenuous outer atmosphere, corona, glowing a milky white. Often explosions on the sun's surface, called prominences, will appear as spectacular bright pink or red clouds stretching high above the lunar limb. This path of totality can be up to 272 kilometers wide, although usually it's a lot less. And the further away you are from the center of the path, the shorter the eclipse duration will be. If you're outside the line of totality, to the north or south of it, you'll only see a partial eclipse, in which only part of the sun's disk will be covered by the moon. The reason a total solar eclipse is only visible over a small part of the Earth is because the moon's shadow is relatively small when it falls on the Earth. On average, the moon orbits about 384,400 kilometers from the Earth. But the moon's orbit around the Earth isn't a perfect circle, it's slightly elliptical, meaning one part of the orbit will be a bit closer to the Earth, about 357,000 kilometers. That's known as perigee. And another part of the lunar orbit will be a bit further away, around 406,000 kilometers. That's known as apogee. And when the moon's orbit takes it a little bit further away, the moon looks a little bit smaller in the sky. And if that coincides with a solar eclipse, it doesn't cover the entire face of the sun. So, instead of a total solar eclipse, the moon's passage across the sun creates an annulus, or a ring of fire, as light from the sun completely surrounds the darkened moon, resulting in an annular eclipse. And that's what happened on June the 21st. The spectacle began at sunrise over the Central African Republic. It then crossed the Congo and Ethiopia, before moving over the Arabian Peninsula, southern Pakistan, northern India and China, and then ending at sunset over the Pacific Ocean. A partial eclipse was visible in North and East Africa, as well as southeastern Europe and most of Asia. And Australia wasn't completely left out. People across the top end were also treated to a sky show, with those in Darwin getting 57 minutes of partial eclipse, while people at the northern tip of Cape York were given 22 minutes of showtime. As the moon continues to slowly move away from the Earth at a rate of about 3 centimeters per year, eventually solar eclipses will become a thing of the past. But you don't need to be on Earth to witness an eclipse, as Jonathan Nally, editor of Australian Sky and Telescope magazine, explains.
Stuart, it's very often said, in fact I've said it a lot, you may have said it yourself, lots of people say it, that we are very lucky here on Earth that we can experience total solar eclipses. All right? This is because the moon and the sun are very, very different in size, but they are just the right sizes, and each of them is just the right distance from Earth, so that when we look at them, they seem to be the same size in the sky.
This is where that 400 comes in.
Yeah, the moon is about 1/400th of the size of the sun, but it's 400 times closer, roughly. So we can get total solar eclipses because the moon can cover up the sun. It doesn't always do so. Sometimes, because the moon's orbit is an ellipse, sometimes it's a little bit further away from us, and when it moves in front of the sun, it doesn't completely cover the sun, and you get an annular eclipse or a ring of fire eclipse, which leaves a little bit of sunlight around the edge of the moon. But as far as total solar eclipses, yeah, everyone always says, gee, we're really, really lucky, and millions and millions and millions of years from now, when the moon will have moved further away from the Earth, because it is getting further and further away by
about the rate your fingernails grow. Yeah.
About the rate your fingernails grow, is it? That's interesting. Goodness gracious.
Yeah, about 3 centimetres a year.
We'll have to get some moon clippers onto it. So we're very, very lucky that we can see these total solar eclipses. So the question's been raised, can you get total solar eclipses on other planets in the solar system with their moons? Okay. So one of our authors, Rod Hill, who's a retired CSIRO researcher, he crunched the numbers and he found out that a few of these moons can actually give you a total solar eclipse. So we're talking about, so the difficulty is that these moons typically throughout our solar system are very small compared to their parent planet. Our moon is very unusual because compared to the Earth, the moon is actually quite big. And some people have sometimes said that the Earth-Moon system is a double planet system. And they sometimes say that also of Pluto with its big moon Charon, which is...
Pluto actually is, because the definition of a binary planetary system involves the barycenter being outside, that is the center of gravity between the two bodies, being outside the circumference of the primary body, in which case that would be Pluto. And in the case of the Pluto-Charon system, it is. The barycenter is outside of Pluto. Technically, occasionally, the Sun and Jupiter do the same thing, with the barycenter of the Sun moving just outside its surface, but not very often. But in the case of the Earth and the Moon, the Terran system be a lovely name for it. It's a good Star Trek-y name. But unfortunately, the center of gravity of the Earth-Moon system always remains beneath the surface of the Earth.
I thought the barycenter was a nightclub on George Street back in the 1950s.
It may well have been.
Well, did I dream that? I might have dreamed that. Anyway, back to this. So the question is, can any of these other moons on other planets cause a total solar eclipse? Well, turns out they can. In fact, there are 12 moons. They belong to Mars, Jupiter, Saturn, Uranus, and Pluto. But they occasionally will cause total solar eclipses, as seen from those planets, but usually only for a few seconds duration, right? And they can be many, many years apart, like hundreds of years apart. So if you didn't know that was going to happen, you would definitely miss it. So I guess the overall thing is, yes, we are very lucky here on Earth because we do have a moon that's the right size and the right distance to give us total solar eclipses, and they happen nice and slowly, so we get to enjoy them, and they come around fairly frequently. So there you go.
Which one of the Martian moons does the eclipsing? Is it Deimos or Phobos?
I think Phobos is the bigger one, isn't it?
Yeah. Phobos is the bigger of the two. It's the one that's going to fall apart first, by the way.
I think I've got a bodily organ called a Phobos, and I think it's going to fall apart.
Oh, dear, oh dear.
The way my body's going.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. This is SpaceTime. Still to come, China launches more spy satellites. And later in the science report, new evidence that climate change is making wet seasons wetter and dry seasons even drier. All that and more still to come on SpaceTime. China is continuing its push to launch a massive fleet of spy satellites designed to provide continuous coverage of the entire Earth's surface. The latest launch takes Beijing's current constellation of Earth observation satellites to over 90. As well as providing near uninterrupted coverage, the growing armada provides ample redundancy for future satellite losses or failures. The latest addition to the fleet was the Gaofen 903 Earth observation satellite, launched aboard a Long March 2D rocket from the Zhukwang Satellite Launch Center in western China's Gansu province. Gaofen 903 is an optical remote sensing satellite capable of providing images with resolutions down to about a meter. The mission payload also included 2 other satellites. Head 5, which will monitor and collect information on shipping and aircraft movements and provide communications for China's Internet of Things, and a small Pico satellite designed to test future technologies in space. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study has found that the patterns of COVID-19 contagion around the world suggest that it may spread like a seasonal respiratory disease. A report in the Journal of the American Medical Association looked at 50 cities, 8 with substantial community spread of COVID-19 and 42 that were either minimally affected or not affected at all. They found that all 8 cities where the virus spread significantly occurred in a narrow latitudinal band between 30 and 50 degrees north, had similar weather patterns with temperatures between 5 and 11 degrees Celsius, and had low humidity levels. The authors say the pattern is consistent with a seasonal respiratory virus, and their findings should help predict which countries will be at highest risk of COVID-19 spreading in the coming weeks. A new study warns that the growing impact of climate change on the planet means wet seasons are going to get a lot wetter, while dry seasons will get even drier. The findings, reported in the journal Nature Communications, shows how global warming will cause rainfall to become far more variable. Researchers found that overall there'll be an increase in annual rainfall averages, especially under the higher emission scenarios being predicted. However, they also found that the variation between the seasons is likely to increase, and regions that already have inconsistent water supplies owing to high seasonal variation in rainfall may experience even more inconsistent water availability in the future. Head congestion is one of the most common symptoms experienced by astronauts during spaceflight, but not much is actually known about what causes it. Now, a report in the Journal of the American Medical Association claims magnetic resonance imaging scans of NASA astronauts both before and after missions may have determined why. The study found that some astronauts who went on long space flights aboard the space station had a buildup of liquid in their inner ear, while astronauts on shorter missions didn't, and this may be what's causing their head congestion. A new study has found that pet owners are turning more and more to homemade or raw-type pet foods instead of the more conventional and safer dry and canned options. A report in the journal Vet Record surveyed more than 3,600 dog and cat owners in Australia, New Zealand, Canada, the UK, and the United States, and compared their findings to data published in earlier studies. They found that most dogs and cats were offered conventional pet food, but only a few were offered it exclusively. Instead, around half of cats and some 2/3 of dogs were being offered homemade or raw options. Different feeding practices were reported in different places, with pet owners in New Zealand and Canada the most likely to feed their dogs and cats an exclusively conventional diet. The authors are calling on vets to educate clients about the nutritional needs of their four-legged friends and the health dangers of feeding them on exclusively raw meat diets. Okay, let's start by remembering the immortal words of the great Dr. Sheldon Cooper from the classic sitcom masterpiece Big Bang Theory. And I quote, "There's absolutely no scientific evidence to support clairvoyance of any kind, which means it's a fraud, profession is a swindle, and its livelihood is dependent on the gullibility of stupid people. No offense intended." With that opinion in mind, we ask the question, can a psychic help you get through these difficult times due to the COVID-19 coronavirus? And Tim Mendham from Australian Skeptic says the answer may not be what you expect.
The story that this came from starts off with the interesting premise that the vast majority of clairvoyants get things wrong. If they say they can see the future, they're lying. All sorts of things like that. So it starts off as a very critical story about psychics and then rapidly deteriorates into a good psychic versus bad psychic promotion, if you like, of how you can tell which is which. And they're offering sort of psychic therapy, astrology. They're throwing astrology in there for amongst the psychic treatments and things. Obviously, in COVID-19, people are very worried, etc. The story, the very concept of saying there are good psychics and bad psychics, just to me, starts off with the wrong premise. You have to say, are there any psychics or no psychics? And certainly all the psychics we've seen and tested have shown that they don't do it, they can't do it. And really, the excuses that psychics make for their errors is quite creative in many ways. But I mean, can a psychic help you? Maybe just to talk to. The same as you talk to your neighbour over the fence or you talk to a friend. But all these things, can a psychic help you get through these difficult times? Yes and no. It depends on the listening abilities of the psychic, I suppose. But I don't think they're going to help you in any way with their psychic abilities, as in, quote, psychic abilities.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio.
Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A. member FDIC.